The ideas expressed in the following presentations are those of the speakers and do not necessarily reflect the views of ACI or its committees. ACI web sessions are recorded at ACI conventions or other concrete industry events and will be made available for viewing free of charge for 1 week. Thereafter, they will be archived on the ACI website or added to ACI's online CEU program, depending on their content.
Thank you. So what I was going to go is a little bit of what we have done through NRMCA, as well as touch a little bit about ACI Committee 329 activities on what we're doing, but basically cover a little bit about where we are in the state of performance-based specification, at least as we see it for private construction in the U.S. Okay, so here goes. So first of all, let's try to define what we mean by prescription and performance. And everybody has a different opinion. There is some opinions that say that if someone furnishes a performance mix, therefore it's a very highly confidential recipe for the cake and we can't tell you about it. But that's not really what we want to talk about, because there are certain standards that you have to comply with in that sense. In general, we started this sort of initiative by the National Ready Mix Concrete Industry. We sort of termed it the P2P initiative, which is sort of a moniker for prescriptive to performance. And the general goal of this was to try to say, okay, if we have to develop the concrete mixture, then try to avoid constraining us as to how we put that mixture together to optimize it for performance and to optimize it for the necessary application. The challenge then happens is that can everybody deliver that, or can the engineer actually specify the actual performance that they want because of just historical inertia where they are in their current specifications. But we feel that when there is a prescriptive specification, the responsibility chain is not very clear. In fact, the courts will say if someone told you, the prescriptive requirements, therefore the person who prescribed it is responsible for whatever happens on that project. And we heard a couple of presentations yesterday from Europe, and they're pretty clear on that. In Canada, they're also very clear on that. What is prescriptive concrete? The responsibility changes to the person who actually specifies that requirement in terms of the achieved performance. And so what the industry feels is that even though they're prescribed, they are still held to blame if the concrete doesn't perform as intended, so might as well evolve to performance-based specifications. This is an ASCE document, American Society of Civil Engineers, and they have a definition, and basically they call a prescriptive specification. This is a broader look at it. Is basically the means and methods are dictated in the contract documents. You're telling the contractor exactly how he needs to achieve something. It's a recipe for completing the product. Sometimes the end result is intended, but it may not be precisely defined. And remember, when you write a specification, you have to have something that is clear and enforceable in that outcome. Contractors, therefore, and this is the big issue here, cannot be faulted if the result is not achieved. That's nice in theory, but that really doesn't happen in reality. Performance specification, on the other side, is a better description of the end result that is needed and not how you get there. Okay, so that's the important part. But then it gets to be challenging to clearly define what exactly do you want in that performance attribute. We have a wide range of concrete members or exposures and stuff like that, and concrete is a beautiful material in that it can be customized for the various properties and exposures that we anticipate. So we can change the requirements as we need to. The contractor then can develop the means and methods to achieve the end result, but the other side of it, there needs to be some straightforward inspection to make sure that what was specified was actually achieved, and that can be also challenging. So when we get back now down to the concrete mixture, this is where National Ready Mix really cares about is what do we mean by performance? And we mean by performance is that you can't come to the concrete producer and say, give me a mix that'll last 100 years, because you can develop a mix, but you have to actually develop. Concrete producer has no knowledge about where this concrete is going. He has no knowledge about the design of the structure and the type of exposure this concrete is going to be. So it is a collaborative process that includes the design, the construction, and the materials used in that, and so it's a joint responsibility of all the stakeholders. But when we talk about performance, we're saying, is there a standard test method that can measure a defined property with defined acceptance criteria in the project specification? And then you don't have many restrictions within that specification that restrict you to put that mix together to meet that performance. So there are no requirements on the composition on the mix. Okay, so that's essentially how we're trying to define performance. Now there are some variations in there when we don't have a reliable or a achievable method or test method to measure a certain property, but we know that there is a historical intent, let's say, that this particular prescriptive requirement meets the intent or deemed to satisfy, then we can consider that as a defined performance because of that. And the example there is that concrete's going to be on a bridge deck. We know that we need low permeability. In that case, if we don't have the effort to, let's say, measure that intended property, we can say, okay, let's defer to using a water cement ratio as long as we know what the exposure condition is relevant to that. ACI also has this other committee, ACI 132, which is a responsibilities committee. This is an interesting document. It's almost bordering on trying to talk a lawyer speak, because it's trying to define the responsibilities of the various stakeholders. And some parts of this document speak to the responsibility as it associates with performance and prescriptive specifications. So if you're interested, take a look at this document and see how that sort of fits in to the overall scheme of things. We have developed several resources as we've been through this journey in developing the P2P initiative. You can go to our website, nrmca.org/P2P. There are guide specifications written in the master spec format. There are guide performance specifications. There is research reports. And then on the right side, this is essentially the specification and practice sheet that I'm going to speak to a little bit about. These primarily 5 prescriptive items that we see very prevalent in specifications in the U.S. that we're trying to say, okay, let's try to evaluate why we have them and maybe remove them from our current specifications. And so I'll go through some of this in this presentation. Now, we in ACI published the ACI 318 building code. We also published the ACI 301 specifications, and primarily the specifications support the code. But most private design firms essentially get license copies of either AIA's master spec or spec link or whatever, and then modify that to their own office design masters. Now the problem with that situation is the section 3300 or 33,000 or however you want to say it for cast in place concrete from AIA master spec is so dated. It is basically going back to 31805 or 3010 thing. So that's why the problem is it doesn't even have the durability exposure classes in the AIA master spec. So the designers who license that particular version of master spec really are not aware of where we are on our codes and standards within ACI. So what we did in our guide to improving specifications is to use that spec format, and you can download this from our website, and we have made it sort of up to date, if you will, to the current 301.16. Okay, so whatever 301 has evolved to, we've tried to incorporate in the master spec format is a means to get to more current standards and more current to the ACI 318 durability type requirements. The guide performance spec is sort of a wishful thinking type document that looks forward, and that's something that we will be trying to use both these types of provisions in the ACI Committee 329 that we're developing some stuff. ACI Committee 329 was formed as a important committee to challenge and move to innovation in the concrete industry. It formed about I don't know, about 5-6 years ago. There was a innovative task group that was formed through the Strategic Development Council. They developed an ITG-8 report within 2 years. It is a pretty comprehensive report on a global look on performance specifications, as well as things that how we might evolve within the industry standards in the U.S. Towards more performance-based requirements. So this report is published. That ITG-8 report was taken by Committee 329 and then made a committee document. document. So it's a guide to evolving to performance-based requirements. The committee is now working on a guide to writing a performance specification for concrete materials. Okay, it will be a guide to writing one. It's not going to be a reference specification like ACI 301 or ACI 301 306.1 or something like that, but it will give you advisory information and it will give you typical clauses, and we've chosen to use the 3300 format or the master spec format as we develop that document, so that hopefully engineers can copy, cut and paste and incorporate these types of provisions in their own office master documents. One of the biggest challenges in moving towards performance is credibility. If you speak to many engineers, they say, we got burnt before, we don't think the industry can deliver. And I think the problem is chicken and egg. If you continue to do business the way it is, then you continue to get what you've always done, is the same concept. And if you don't challenge the industry to move towards a different mode of how we do business, you will continue to do that. New York City, and Kaz will probably talk a little bit more about that, is a classical example of where we had the highest quality in the 60s, we evolved, went backwards, and then we're going forward again. So we're looking at, can the industry deliver? We're looking at industry reputation. Do they have the right quality system? Do they have the right people? Do they have plants and production facilities that meet at least the basic minimum industry standards? So there are ways that you can do that. Various companies do have a reputation in the local market. They have knowledgeable people who can provide and partner with the various stakeholders, whether it's the contractor or design engineer, to deliver and develop what you need for a particular project. Whether it's a self-consolidating concrete mixes, you see all the honeycombs in this building, well, it was done before SCC actually came in. So, you know, that type of stuff can be done nowadays with beautiful stuff, and, you know, there has to be that partnership between the engineer, the contractor, and the concrete producer to develop the necessary solutions for various projects. And that happens in various markets and to some degree. The challenge over there sometimes happens with low bid. And low bid is the law in many cases for public agencies, but that might be that you get what you pay for in many cases. Certifications can be a way to make sure that you have the right team on that project. NRMCA does have a certification program for plants and trucks. We have about 2,800 plants certified in the U.S. and also abroad. There are certification programs to ensure that you have competent technical people. NRMCA has concrete technologist certification program going from level 2, level 3, level 4, talking about durability requirements in the building code. In many cases, some of these guys know much more than some of the design engineers writing specifications related to concrete materials. Okay, ACI has recently developed a concrete quality technical manager, very comprehensive certification program that takes, I think, basically the manual of concrete practice as it's relevant to concrete mixtures and tests people on that. So take a look at that. That's just getting off the ground within ACI. And one of the things that NRMCA did when we started this initiative is we got a few design professionals together and said, how do we address this credibility issue? And they said, well, you build it, we will come. So we sort of developed what's called a minimum standard quality certification for the industry. And this is basically making sure that they have at least a minimum standard for a quality management system, and they actually conform and follow that quality management system that they have defined for themselves with minimum criteria addressed in this certification program. We have built it, they have not come. We're looking for people to either specify it or to start using it. But it covers a pretty comprehensive, where we look at the quality plan, where we look at the personnel qualifications, their ability to test the concrete and ingredient materials, how did they manage their materials that they get into their plants, that their production facilities meet minimum standards, et cetera, et cetera. So this process naturally in a quality management system is hopefully a process of continuous improvement. So what are the benefits of performance? You have to have that right message, and the message will differ depending on who you're talking to. For the producer, it might be, yeah, I can save on some material costs and therefore increase my profitability. From the contractor, yes, I will have the thing that will deliver it, or I can get the mix that I can work with easier. For the designer, I have a quality system or a quality team that's working for me, and therefore I'll be on time, on schedule, within budget. And so it depends on who you're talking to. So it's the various stakeholders, the message might be different. and you have to find out what interests that particular stakeholder, whether it's quality, reliability in the construction process, the change of responsibility. Many engineers don't want to get involved with concrete mixtures. They want to delegate that responsibility. We want to optimize. We want to be sustainable. We want to reduce cost. All those things, we can develop these messages when we talk to the different stakeholders involved in that process. So how do we start? I mean, we don't have to make it complicated. That's the important thing. Can't make a drastic change so that people say, what are you talking about, and don't want to go there. So you have to make things. So the first step, that basically how are specifications developed? Well, for the most part in private design firms, either they get AIA master spec and we get, or CSI spec link, and start modifying that to their general provisions. There is also general reference to ACI 301 as a cover-all, that it cover-all situation. Then you add on specific provisions as pertinent to your project. And so that's why the problem has been that AIA master spec is so dated, and we have developed comprehensive comments and submitted them to AIA to say, you know, at least change your specification. We've given them specific language changes and rationale for them to change it. And so they're trying to work through that process. Hopefully we will get them. And I think that dialogue between, let's say, ACI or our industry and AIA doesn't exist to the degree that it should. So our first step, let's look at our specifications, see where we do have prescriptive requirements in our specification. This is just a listing of some of the prescriptive requirements that we see in most specifications, and I'm not going to go through this in any detail. So what we looked at is, when we took this list and sent it to the ready-mix concrete industry, we said, okay, what do we need to look at? What are these prescriptive requirements that cause you most heartburn, if you will? The first step is look at and minimize prescriptive requirements if you can figure out why it's there in the first place, and maybe remove it. The next step is then develop the properties you require by application, both for fresh concrete. That would be a communication between the contractor and the producer, and most engineers probably don't need to tell the contractor what slump he needs to use. Let the contractor choose a slump depending on his placement methods or other types of properties. Really, you need to be informed about what that choice is, but that's something that you should leave between the contractor and the producer. Hardened concrete, naturally, the designer wants to know about the hardened concrete and whether you can achieve that. And the hardened concrete will depend on the type of member you're constructing and the exposure that member is going to see in service. So foundations will have different concrete, slabs, beams, interior, exterior. You can then establish requirements by member type. Naturally, when you get to transportation, you have bridge decks that may need something, substructure needs something else, pavements that need a totally different concrete mixture. So by application, develop the necessary properties. So in our industry survey, we sent up the list of the prescriptive requirements, and we asked them, which one of these cause you most heartburn? How often do you see them? Does this restrict you from optimizing the mix? Does it affect your ability to impact the cost of your concrete mixtures? Does it really do you think it really improves the performance? So we sort of ranked these listings, and they sort of came up to the top that the top 5 of these would be these types of things: invoking a maximum water cement ratio when it's not required. And you'll see a typical clause saying all the concrete on this project shall have a maximum water cement ratio of 0.4. Why? We don't know. It's there. It's good. It's better to have low water cement ratio than not. So you have this list of things, and I'm going to go through some of that as we go through this presentation. Then we actually asked the producers to send us their specifications that they are working on in projects, and we reviewed, between Karthik and myself, reviewed about 102 specifications to identify whether these clauses existed in these specifications. We did not get public agency specifications. It's all private work, and these were the types of projects that these specifications represented. So this was where we saw the sort of state of prescription, if you will, in our analysis of the current specification. A restriction on the quantity of SCM as a general requirement. That means you cannot use more than so much fly ash or slag in your concrete mixtures, was there in 85% of the specifications that we reviewed. Where do we have this in industry standards? In ACI, the only restriction that we have this in is when a member is designated or assigned to an exposure class F3, where it's going to be exposed to freezing and thawing exposure and the application of de-icing salts. Okay? Maximum water cement ratio when not applicable. This tends to be a two-pronged problem. One is that it's an interior member, you don't really have any exposure condition, but there's a water cement ratio limit on that. Okay, so that's one of the things. The second type of problem is where you have a water cement ratio and that the strength that is specified is totally not in sync with the water cement ratio. And so that's another problem where you have, let's say, a 0.4 water cement ratio and a 3,000 psi concrete mixture requirement. And that's sort of a disconnect that causes a little bit of issues over there because they're two different mixes. Okay, 0.4 water cement ratio mix is totally different from a 3,000 psi mix. Minimum cement content. We see this in 46% of the standards. In our industry standards, we have a minimum cement content in the ACI 350 code that was recently instituted. Not sure why. ACI 301 has minimum cement contents for finishability of floors, and the values of the cement contents are relatively low. Restriction on the type of SCMs, and then restriction on aggregate grading. So we see that these types of things or clauses are there in the spec, that percentage of the time. So the overall average is sort of a ballpark, as that we are 51% prescriptive. Okay, so that's just a general theme of that. So if we can start eliminating each one of these, we can get towards, let's say, less prescriptive, hopefully more performance-oriented. If ACI standards were really followed, none of these would be an issue because you have a specific reason that these requirements are instituted in industry standards. Okay, we wrote an article. You can read this article if you're interested in more detail in August 2015, Concrete International, and then we developed this what we call the specification and practice sheets. These were also included in that particular issue of Concrete International, and if you're interested, you can go to our website. And these are 2-pagers, back and front and back, and basically we go through the process. What is the requirement that we see? Is this requirement in the industry standard? What do we think is the basis for this requirement? What are the implications? What are the problems caused by this requirement? And we suggest some alternatives and a benefit for that alternative. So you can look at that and see if this helps, or you can distribute it to engineers if you feel that this is something that can help you change a specification you deal with. So we have specification and practice sheets are the one is limits on quantities of SCMs, limits on water cement ratio. The third one is on minimum cement content in specifications, restriction on the type and characteristics of fly ash, and restriction on grading. So those are the 5 topics that we chose to do because these were the highest rated or the ones that caused most problems. Now, we have brought some of these documents into ACI committees. The number 3, minimum cementitious material content, has been taken up by ACI 329, and it's actually been approved and will be on the street pretty soon. Okay, we are a performance-oriented committee, so we actually balloted this document and approved it before we got even permission from TAC to develop it. ACI Committee 232 is a slower reacting committee. They are actually still discussing whether they want to do this technical note. This is called a technical note in ACI. So it's an easier and briefer type topic that will address one specific issue, and many committees are using technical notes to disseminate information in a faster time frame. So we chose to do this. So you'll see the technical note from 329 come out pretty soon, and then I think the committee 232 on fly ash is balloting the other one pretty soon also. So let's go through this a little bit real briefly. Restrictions caused by SCMs. You know, the SCM quantity, you see that you have various issues where the quantity of SCM may not be adequate for durability and stuff like that. So you do have various things like that listed. Maximum water cement ratio. Why do we need it? When we have a specific exposure class in concrete, then as defined by the exposure class definitions in ACI 318 and 301, there are specific reasons when you would use the water cement ratio. So try to stick to the exposure class requirements requirements for water cement ratio definitions. When we have a low water cement ratio, we really have a problem sometimes with workability when it gets too low, when it's unnecessary for certain applications. You also tend to increase the paste volume of the mix, which causes other problems with the concrete mixtures and stuff like that. And it's really not necessary for most of our applications to specify a water cement ratio less than 0.4, unless you're getting into very severe type exposures. Minimum cement content. We really don't have any restrictions for minimum cement content in our standards. There's nothing in ACI 318. There are some cases in ACI 350 for environmental structures. And for floors, you can see that the minimum cement content for floors to get enough paste is relatively low, but it can be, there's an out to that. If you can do a mock-up and actually evaluate a test slab, you can use less than the minimum cement content. Most state highway agency specs have their classes of concrete defined by cement content, and you'll see that in European standards as well. So we see that when you have a minimum cement content, sometimes these numbers are very high. It does impact the workability. You do increase the paste volume of the mix that has increased potential for cracking. You have other problems, and all these restrictions are discussed in our SIPs. The other one that we see is that available source of fly ash, which is now getting to be a problem, is restricted from use because of additional restrictions within a specification, such as not permitting the use of Class C ash or changing the loss on ignition requirements and stuff like that, that basically say that available supply cannot be used. And that's one of the problems. There are no specific restrictions within our industry standards on the specific fly ash other than it meets ASTM C618. The thing is that producers develop a history and comfort with the particular materials that they use, and if they're forced to use something else, that they don't have that history. Aggregate grading limits. Again, this you'll see mainly on floor type concrete. The primary goal is to change workability, probably to change the curling or shrinkage characteristics of the mix, and those sorts of cause other problems. Generally, in many markets, we cannot meet the grading requirements that are specified. It may need a lot more storage. We understand the general technical intent, but if there is a performance measure such as shrinkage that can be specified as an alternate, recommend that you do that. So the intended performance may not be achieved. The requirement generally cannot be verified during a project on the grading limits other than looking at a spreadsheet and those sorts of things. And the basic message here is that optimizing the grading of the concrete is a step in the proportioning of the mixture, and it's really not a specification requirement. So changing specifications, there are various documents you can look like. You can probably define the requirements for basic code requirements by member type and add on specific performance requirements as needed. This is an example of the Washington DOT's change from a totally prescriptive type concrete to now a more performance type mix. And this speaker was supposed to attend, but as an example of some state highway agencies that are getting more progressive in evolving to performance-based specification. Just a mention of the Federal Highways program towards performance engineered mixtures for concrete pavements. This is now developed as a provisional standard in AASHTO. The primary goal is to improve the durability and service life of concrete pavements. The standard is ASTRO PP484. It's a guide specification that states can adopt, and that will be available next month from ASTRO as a provisional standard. And that's what it is called. It's Developing Performance Engineered Mix for Concrete Pavements. And you can't read this, but it has various properties. It has various options for those properties, and it's pick one. Don't pick more than one for each of these. So you pick one that you can feel comfortable with. It could be prescriptive, it could be performance, it could be model-based. So they are evolving towards that, and in a 5-year pool fund study, they will be actually evaluating all these types of properties in paving mixes on actual projects, on paving projects. If you want more information on that, Peter Taylor with the Iowa State Concrete Pavement Technology Center, it would be the primary contact on that. So I will end performance-based specifications. It's where the future is, or I think it should be. Thank you.